Number 11. Draw a graph that has the following characteristics. At x equals 2, the graph is discontinuous. At x equals 3, the graph is continuous and differentiable. And at x equals 5, the graph is continuous but not differentiable. Alright, so at x equals 2, it's discontinuous. So we could either have a hole or an asymptote. Take your pick. Okay, and then at x equals 3, the graph is continuous and differentiable, so it's just a nice smooth curve there, so everything's happening that should be. And then at x equals 5, the graph is continuous but not differentiable. The only way that that could happen would be if there's a sharp turn. So just a sample picture of what this might look like. At x equals 2, there's going to be some sort of hole or asymptote. I'm going to make a hole, so it's coming down with the hole till then. At x equals 3, there's just a smooth curve. And then when I get to x equals 5, there has to be a sharp turn. So it's going to look something like that. We could also have something with an asymptote in it. Number 12, a curve has slope 3x squared plus 4 at each point xy on the curve. Find an equation for the curve if it passes through the point 210. All right, so if this is the slope, this is the derivative, and we want the curve. So to get from the derivative back to the curve, we need to take the integral of 3x squared plus 4. So our curve is going to be y equals, and since there's a plus sign, we can separate it into two integrals. So I'm going to get the integral of 3x squared would be x cubed, plus the integral of 4 would be 4x, and don't forget your plus c. And now we'll use the 210 to find our c, so we'll get 10 equals 2 cubed plus 4 times 2 plus c, so we'll get 10 equals 8 plus c. We'll get 10 equals 16 plus c, so c will equal negative 6. So our curve will be y equals x cubed plus 4x minus 6. Right, number 13, the first derivative of a function f is defined by f prime equals cosine x squared minus 2 for all x's between 0 and 3. On what interval is f decreasing? Well, if f is decreasing, f prime will be negative. So we really want an f prime chart, and since we already have f prime, what we can do is find a picture of f prime and find out where it's negative. So if you, first of all, go ahead and graph this and just change your window to just be the x is going from 0 to 3, you're going to get a picture that looks like that. So we need to find these critical values, and if you use the 0 feature of your calculator, you can do that. And I'm going to make my f prime chart, and those zeros are going to be 0.655, 1.890, and 2.591. And then if we want to find out where f prime is positive and negative, f prime is below the x-axis till it gets to this first 0, so it's going to be negative, and then it's above the x-axis, so it'll be positive, and then we dip again below, and then above. And if I want to find where f is decreasing, I want to know where f prime is negative, which will be on these two intervals, and since I start at 0, we'll go from 0 to 0.655, and again from 1.890 to 2.591. Alrighty. Number 14, the derivative of the function f is given by f prime is equal to x squared minus 2x sine x. How many points of inflection does the graph of f have on the interval negative 3 to 3, and then what are the coordinates of the points of inflection? Okay, so if we're at f prime and I want to go to points of inflection, I need to know something about f double prime. So we're not going to find f double prime because we're in a calculator section, so I'm going to go ahead and graph f prime. And again, since it's from negative 3 to 3, I'm changing my x window. I'm going to get a picture that looks something like this if I do that. And if I want to know points of inflection from, if this is f prime and I want to know f double prime, I'm going to be looking at the slopes. So if I made an f double prime chart, the slopes are going down until, or negative till I get to this value. Then they're positive, and then they're going up, and then the slopes are negative till I get to that value and back up again. So those values, to get these values, you could use the minimum feature on your calculator, and for this one you can use the maximum. Those values are negative 1.307, 0, and 1.307. And so since the slopes are negative till I get down to here, we'll have negative and then positive and then negative and then positive. And so if I want to know how many points of inflection there are, how many times does f double prime change sign? Changes once, twice, 3 times. So 3 times. And then what are the x coordinates? Well, we just found them. So they're at x equals negative 1.307, x equals 0, and x equals 1.307. Okay, problem 15. A particle moves along a straight line with velocity given by that formula. For time t greater than or equal to 0, what is the acceleration of the particle? Well, acceleration is the derivative of the velocity. And since we want to find it at 4, we just want to find the derivative of the velocity at 4. And since we know a value and we're on the calculator section, we are going to use Math 8. And if you use Math 8 and just plug this in, you will end up getting 695.905. Okay, number 16, what is the average value of y equals e to the 3x over x squared plus 1 on the closed interval from negative 2 to 4? Well, average value is the formula 1 over b minus a times the integral from a to b of your function. So we're going to have 1 over 4 minus negative 2, and then the integral from negative 2 to 4 of our function. Okay, and then we're going to let our calculator do all of the work for us. And if we do that, we'll get 644.052. Right, problem 17. Let f be the function given by f of x equals 3x ln x. On what interval is the graph concave up? Well, we get to use our calculator. If I'm looking for a graph concave up and I'm given the function, I'm just going to be looking for where does the graph look concave up like a cup. So we're just going to go ahead and graph it. And if we graph the function, we should end up getting something that looks just like that. And so if I want to know where does it look concave up like a cup, everywhere where I see the picture, which would be starting at 0 until I get to infinity. So if I go 0 to infinity, we got it. I'm not going to bracket the 0 side because we can't plug 0 into this function because ln of 0 is undefined. Okay, 18. The rate of change of the number of people standing in line for Thrilling Thunder is given by this formula. Write an integral expression that gives the change in number of people in line during the time the number of people standing in line is decreasing. So we want to know the change in the number of people. So we want to know how many people. And this is the rate of the number of people. So to get from a rate back to a number of people, I know that I have to take the integral of the rate. The question is just from where to where. And we want to find it during the time the number of people standing in line is decreasing. Well, if the number of people is decreasing, that would mean that the rate is negative. So we just need to find where is the rate negative. So I need to find where does 4t squared minus 3t minus 7, where is that less than 0? Where is it negative? And so I graphed r of t, and it looks like this. Okay, we don't care about this side because t is bigger than 0. And then if I found this is the rate and I need to know where is it less than 0, so I need to know where is it negative, which is right in this spot right here. And that's going to go from x equals 0 until where it touches the 0. And again, I use the 0 feature to help me find that. And that would be at 1.75. So this would be my answer right there. Okay, 19. The velocity in feet per second of a particle moving along the x-axis is given by the function right there. What is the average acceleration of the particle from 0 to 2? So average, again, is 1 over b minus a times the integral from a to b of whatever function we're talking about. And this one is the average acceleration, so I need the acceleration. All right, so first of all, we're going to have 1 over 2 minus 0. The integral is 0 to 2, and then I need the acceleration. Well, I'm given the velocity, so to get to acceleration, we know I'm going to have to take the derivative of velocity, and when I do that, the derivative of 3t is 3, plus the derivative of 2e to the 2t is 4e to the 2t, using e to the u du, and from here we can use the capabilities of our calculator to find that, and that is going to be 56.598. Okay, number 20. Let g be the function given by g of x equals the integral from 3 to x of that function for 0 to 7/4. On what interval is g decreasing? Well, if g is decreasing, we would know that g prime is negative. So we need to know some information about g prime. Well, going back to this type of problem, we know that g is the area under the curve. We know that g prime is the curve. So we just need to look at the curve. So we just need to look at this curve and see what's happening. Okay, if you graph this curve and have this be your x-min and x-max, this is what your graph is going to look like. Something like boom, 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 something like that. And then we just need to find out where is this curve negative. So this curve would be negative right here. So I'm just going to make myself a G prime chart. It's 0. So if I looked up if I did the 0 feature, it's 0 at 1.162 and 1.677. G prime is above the x-axis, before that, below, and then above. And so if I'm looking for where is G prime negative, it would be in this spot right here. So on what intervals? It would be from 1.162 to 1.677. And there we go.